In front of me I hold different forms that I have used in order to make a modular form made of silicone at the end. But I have first of all used the 3D printed form at different sizes to see whether hydrogel has resolution. And hydrogel doesn't have resolution, so that means if I would like to get all of those beautiful imprints that are more or less this size, I wouldn't be able to do it that much, just because hydrogel, when molded, it doesn't really display that much of resolution. Only it displays it straight after molding, but after an hour or so it disappears. So that was one thing that was very important for me, because by testing this resolution, I know I can only go for very modular and quite big shapes rather than, you know, beautiful imprints. Now I have used this form for hydrogel to be basically imprinted. Hydrogel has been filled in all of that form, and this is how it looks one day after it has been imprinted. So you can see that the size of this is actually quite significant. So this stayed in the room temperature, okay, and the size has decreased, showing the shrinkage. If you compare newly made hydrogel without any sort of reinforcement and hydrogel with reinforcement, you can see that reinforcement also keeps hydrogel to better size. So you can see that in comparison to the first form, the sample reinforced with wood fibers holds on much better. Another very important thing when molding with hydrogel is to make sure that it can hold on to the lifespan that we wanted to design it to. So hydrogel is basically biodegraded by breakage of calcium chloride bond. Another very important thing when molding with hydrogel is to make sure that we're designing the structure of hydrogel with the chemicals that stop the biodegradation process. So I have used 3 different chemicals. One of them is sodium dihydroacetate, another one is rosemary extract, and the third one is nanosilver. So the differences between not applying any of those chemicals is basically that hydrogel will start getting mold, and it will start basically being digested enzymically by bioorganisms, and it will start cracking as in that sample, so the calcium chloride bond will be digested. This sample has been basically made with deionized water, and also it had vitamin C and nanosilver added to it, so you can see that it holds on to nice color, so it doesn't change the coloration of hydrogel. This sample is basically hydrogel with rosemary extract, and this rosemary extract is basically starting to turn reddish and into even browns, and this is because extract of rosemary it intensifies with time, and it turns into this, which might be seen as limitation. This is hydrogel with application of sodium dihydroacetate, so it changed the color to yellowish green, also a limitation. So out of those 3, the best coloration will be kept with nanosilver, but nanosilver is more expensive, so it is basically a very thin border between choosing sodium dihydroacetate, rosemary extract, or nanosilver. So those are the samples from October 2019 to nowadays, okay, and those samples basically show that these extracts of rosemary and also sodium dihydroacetate work, as hydrogel has shrunk down with time, okay, but there is no mold or there is no digestion. Okay, so that means that we can design hydrogel in the way to encompass certain lifespan. So this is from October until now, and it's very firm. Like, it's not any longer flimsy. It's all the water has evaporated, and I can heat it. And one more thing I wanted to show is basically how the size of the hydrogel sample that used to be filling all of this petri dish has shrunk down to this size from October until now. Study of hydrogel reinforcement. I have in front of me 3 samples. 2 of them are being reinforced with wood fibers that are recycled from the chair that hasn't been used, which is basically somebody else's rubbish. And another one is a textile fiber, and the reason why I have been using this because they prove to increase the reinforcement of hydrogel compared to the hydrogel without reinforcement. So you can see that this reinforcement is quite rigid. If I do this, it still maintains the form and it's not as flexible. Okay, and also if I do it with that one is more flexible. However, it still keeps the hydrogel together, so it doesn't cause cracks. If you look at hydrogel by itself, it has cracks. Okay, and the reason why they are cracks is because nothing holds it in place. So after a certain period of time, it will basically start biodegrade. In front of me I'm holding the mold out of which the hydrogel tiles have been made. Okay, this reinforcement with the string has been quite successful because although at first when reinforced it has been very flexible, however after it dried out it's totally rigid and I can do anything with it. It doesn't change the shape, it's just great. Another type of reinforcement is the reinforcement with the wood fibers. We can see that the size did not change much since the first day after the water has evaporated greatly. So we can see that the size was like this, and then it shrinked, but it basically compressed the pieces of the material together, and we can see that those pieces of material since then didn't change much in shape, so it's really good. However, the bigger pieces of wood fibers do contribute to cracks, and cracks are obviously the first principle of biodegradation, so we would prefer to avoid the cracks in hydrogel structure, which we have done by utilizing smaller pieces of wood fibers, and this maintained the structure quite well. We can see it didn't change the shape much. It maintained the bigger geometry. Also, it has stayed the same size as after the first day evaporation. So wood fibers as well as string fibers work really good. And yeah, so this is something that definitely helps to maintain the shape, and it also maintains quite well rigidity and holds the hydrogel together. So this is one way of using hydrogel in construction sector.